Hi, and welcome back to Grassroots Crypto, where I like to teach people about crypto. And in this video, I'm going to be doing a guide on how to develop with THORChain. We'll be looking at what is THORChain and what it can do, how to send assets to THORChain. Then we'll get a bit technical and have a look at some endpoints that do a lot of the hard work for you. Then we'll wrap it up. By the end of the video, you will know enough to get started to develop with THORChain. If you're new here, don't forget to like and subscribe to see more content like this. Right, let's get started. So what is THORChain? THORChain is a decentralized cross-chain liquidity protocol that deals specifically with native layer 1 assets. THORChain offers a number of services: the swap, save, and lend. Let's look at these services in a bit more detail to get a better understanding. So with layer 1 swaps, THORChain deals with native assets. So that's native Bitcoin, native Ether on the actual native chain, and that enables you to swap, as an example, native Bitcoin with native Ethereum. There's no wrapping, there's no atomic swaps and stuff like that. It utilizes liquidity pools like any other automated market maker, except it's going to have Rune in each pool on the other side. So you'll have, say, BTC and Rune in the Bitcoin pool, Ethereum and Rune in the ETH pool, and so on and so forth for USD. So actual like ERC tokens on a chain, and every pool is going to be a 50% asset and 50% Rune. For swapping, there's kind of like two sets of swaps. You can swap from asset to Rune or other way around, and that's known as a single swap. In order to go from Bitcoin to Ethereum, it's actually known as a double swap, because you're going to be swapping across two pools where you go from Bitcoin to Rune, and then that moves across from Rune to Ethereum, as you can see through this nice little picture here. Now, it is important to note that the swap fee, otherwise known as the slip fee, is determined by the size of the swap and the depth of the pool. Or another way of saying it, it's how much you're bringing the pool out of balance because of your swap, and of course that is also determined by the depth. It's very similar to Ethereum's XYK model, except it's been expanded upon, or there's an evolution of it, and you can read more about it here inside of the docs. Let's have a look at savings. Savings allows a user to earn in-kind yield on their native assets. Savers' deposit reside within their respective liquidity pool. Savers are not exposed to the impermanent loss risk whilst they are in the savings vault, and they receive about half of the income that's generated within the liquidity pool. So as I said, a saver's deposit cannot be eaten away through impermanent loss. However, there are entry and exit fees. With savers, there are entry and exit fees, and I just wanted to quickly go over them. So when you enter savings, what's actually going on when you were, say, to deposit 1 BTC, that BTC is then taken and swapped to Rune. So there's an L1 swap here, and that incurs slip. That Rune is then sent across and burnt in order to mint synthetic Bitcoin. And that synthetic Bitcoin is actually what goes into the vault and earns yield. When you withdraw, it's the same process, just in reverse. Synthetic BTC comes out of the vault, that is actually burnt, and then the equivalent Rune is minted. That Rune is then swapped for native Bitcoin. So we have two swaps on the way in and then two swaps on the way out. So they're the entry and exit fees you need to be aware of. And then that's why breaking it up into smaller transactions, you can reduce your slip fees. So you want to be a bit smart about it. You can learn more about savers by going to the docs and reading through here, as well as looking at this article here. You can have a look at the yield for the different pools here. And savers is only available to native assets. You can't do it on ERC20 and stablecoins currently. This will show what assets are available for savers and what the current yield is. There is a cap for savers. However, in time that should never actually be hit because of some new functionality to come into the network. And I made a video here that goes through all the mechanics of the savers, a bit about the synths, and why the cap shouldn't be hit. Then we have lending, which is not yet released. In the simplest way, a lender deposits collateral into THORChain, and then they can take out any asset as a debt. As an example, I'll put in 1 BTC and I have a collateralization ratio of 200%. So I get approximately half a BTC worth in Tether, and I could do this in any other asset that I wanted, and then that lender can go use that Tether for whatever they wanted, and there's going to be no expiry, no interest, and no liquidations. Again, I did make a video on lending, so you can have a look at the specific details here through quite a long 48-minute video there. So just to give a bit of an overview of THORChain, we have a number of roles here. So we have the swappers and arbitragers. Obviously these take the pool out of balance, these put it back into balance. We have liquidity providers and savers, and they provide liquidity to the pools, which deepen the pools. And then we have node operators, and node operators run and secure the network. Node operators need to bond rune as economic security, and that rune, or the sum of the rune, needs to be more than the sum of the liquidity inside the liquidity pools. So when users come along and they swap assets or they enter and exit savers, they produce fees, swap fees, and that generates income. That, along with block rewards, generates income that goes through the incentive pendulum to liquidity providers and nodes. Nodes also observe the THORChain blockchain as well as external blockchains to have a look for transactions that are entering THORChain or being sent to the vault, so it can take action accordingly. Having a look at the THORChain stack, THORChain runs on normal node hardware, and a lot of it's cloud provider, like within AWS, DigitalOcean. However, some of it is a bare metal setup, as in like physical hardware set up in someone's house. Then there's the actual THORNode deployment that uses Kubernetes, and that includes many things like a full node of every chain, as well as the THORNode daemon. Then we look at the THORChain blockchain, as THORChain is not only a liquidity protocol, but it's also the name of the blockchain. And that is a Cosmos app that utilizes Tendermint for all the networking consensus stuff. Within the blockchain itself is all of the business logic and AMM type of logic. THORChain exposes a number of endpoints, being the THORNode REST API, as well as the Midgard API. The THORNode API comes directly from the THORNode blockchain data here. And then the Midgard is getting its data from THORNode. Comparing THORChain to something like UniSwap, THORChain, as I said, has its own blockchain, and as well as UniSwap, leverages the Ethereum blockchain. THORChain has its own AMM business rules and logic that's contained within the replicated state machine and exposes those APIs that I talked about. Whereas Uniswap has all of its logic within the smart contracts, and then it also has a web UI layer. THORChain doesn't have an actual web UI layer at all, and that's why the THORChain has set up incentives in order to incentivize companies to come along and utilize THORChain. And these incentives are affiliate fees, which we'll talk about in a minute. So this is a bit of an overview of the THORNode app, and this is what would be in a THORNode deployment. So what would be in here? We have the THORChain daemon, as we talked about up there, and then there's THORNode API, and that gets raw blockchain information from the THORChain blockchain. And then the Midgard gets its information from THORNode. There's Bifrost that does all the chain observations as well as signing and stuff like that. THORNode is also sending its bond and securing assets within the Asgard vault. Just before we move on, let's talk a bit about the aggregation pattern. Enabling native swaps is a powerful thing, but by doing so, THORChain is also able to connect isolated ecosystems together. So you could swap, as an example, native Bitcoin to Link within the Ethereum landscape, or you could swap Frax within the Avalanche ecosystem to native Bitcoin. And it all seems like one transaction to the user. This helps build volume as users want to be able to exchange assets across ecosystems without going through a centralized exchange. The aggregation pattern is out of the scope of this video, but you can find out more information in the dev docs here, as well as some EVM implementation examples. So THORChain is a fully working backend, but it has no front end, as we saw here. It has the incentive structure in place via what is known as affiliate fees to promote organizations to build on top of THORChain, and which provides a revenue stream for doing so. So THORChain has the backend, it just needs organizations to develop front ends and to bring and educate users. Let's talk more about these affiliate fees. Affiliate fees is a way you can essentially earn income from sending traffic to THORChain. Affiliate fee amounts can be up to 10% for a swap or a liquidity edition, which also includes a savers edition. THORChain has affiliate fees, allowing interfaces to earn money for using THORChain, and you can read more information here in the dev docs, as well as going to this Medium article. Let's talk about sending assets and instructions to THORChain. So when you send a BTC transaction to THORChain, you're sending it to a specific address, and this address is within a special vault known as a threshold signature scheme vault. This is created by active node operators or validators and has a chain address for each chain it supports. So when you send that transaction to THORChain, you're sending it to a TSS vault. The vault requires a 2/3 majority of active node operators to sign the transactions before the funds can be left. So this is what provides a lot of security for THORChain. You can think of this TSS/Asgard vault like a supercharged cross-chain multi-sig wallet, but there is a rotating membership and there is no private keys. There's an endpoint known as the inbound addresses, and then this is where the actual physical chain addresses are. So if we're talking about the BTC address or the BTC kind of wallet, this thing here is what is going to be this thing here when I'm talking about it. Having said all that, there's actually 5 TSS vaults within THORChain, and only one of these, you say active vaults, is published within this specific endpoint. The active one is based on the most bonded to asset ratio within that particular vault. And they can change because of liquidity movements, additions, withdrawals, and stuff like that. And then every 3 days, there's a churn and all the vaults, well, there'll be a new set of vaults created, and then all the funds will move to that new set of vault. The main takeaway point is this particular address is constantly going to change. So you never want to cache it. You kind of want to just get that endpoint, get the address and send it there straight away, and never hold a copy or cache it in any way. So now that we've looked at the inbound addresses endpoint, let's go through this in a bit more detail. So first we have the address, and it's obviously going to be the address for the chain. So as an example, we've got BNB address. There's one for every chain within THORChain. Then we have the halts, and they have different halts for different things. So that's liquidity pool actions, trading halts, there's global trading halts, chain halts. So if any of these are true, then that particular halt is enforced. Then we have the dust threshold, and this is the minimum amount that is needed. So in this case, 10,000 sats, else THORChain is going to ignore it. There's a different value for every chain. This is also important when withdrawing savers or withdrawing liquidity providers, because this will be the minimum amount you would need in order to send that transaction for that instruction. Then we have the gas rate, and this will be in sats per byte. And this does change often because this is going to be the average that THORChain works out based off the history. And then it has the gas rate units, which is obviously sats per byte. For inbounds, this is the recommendation to use, say, as it is now, 16 sats per byte to ensure that the transaction goes into the next block. Whilst interfaces will actually set the inbound transaction, it is recommended to look and use this to ensure that users are not waiting too long. Say, as an example, they did 2 sats per byte and it's just sitting in the mempool and never actually confirmed. Then there's the outbound fee. This is the fee that THORChain will charge when liquidity leaves the network. So this is either going to be the outbound of a swap, withdrawing from savers or liquidity providers, anytime liquidity leaves the network for this particular BTC. As I said, this will change depending on the chain. This fee also includes the network fee that THORChain will take. Then we have the outbound transaction size, and this is what's used in the calculation of transactions. So if we go to Ethereum, then we're going to have an Ethereum address. And what's different about this between Ethereum as well as AVAX, so any type of EVM-based chain, is there's a router. All Ether and ERC20 should be sent to the router address and not to the Ethereum address. Whilst Ether inbounds will reside there and you could send it there, again, is recommended to send it to the router and not the actual address. If you have a look at Avalanche, you have the same thing here. So that's it for the inbound addresses. So when we're talking about we need to send funds to THORChain for whatever reason, for adding and removing or swapping, we're sending it to a specific address, whether it's going to be the Bitcoin address, the Ethereum address, the AVAX address, the Cosmos address. These are the specific addresses here. So this is the page where you're going to get all the information and the links to the Midgard and the THORNode endpoints. So if we go ahead and click on any one of these, you're going to get the doc for THORNode. So within here is all the APIs, the THORNode APIs that you can actually connect to. And they're pretty good. There's lots of really good information here. So if we go ahead and let's have a look at the vaults. We can have a look at the actual Asgard or those TSS vaults. And it has a really good feature. You can just do execute as an example. And it's going to give you that information as well as the URL to execute and all that type of stuff. These endpoints also support the Open API, so you can get that YAML and put that into, or generate these APIs in any language that you want, whether it's going to be C# or Java or anything like that. This has been done through xChain, through the Midgard and the THORNode packages, so you can just search them out and utilize them if you use JavaScript. Also, you can get the positions. We're gonna go through specifically those two in a little bit, as well as these really good quote endpoints that take care of all the hard work for you. And we'll be going through particularly these three in detail. So when talking about these endpoints specifically, like THORNode and stuff like that, these are run by specific organizations, like you got 9 Realms here and THORNSwap. So they're obviously paying to keep these alive, and I know that a lot of people use the 9 Realms endpoint, and there are restrictions on how often that can be used and so on and so forth. So just take note of here, if you're going to be going in full tilt, you might want to consider setting up your own nodes, so therefore you can run your own instance of THORNode and Midgard and get your information that way. So let's have a look at Midgard. And you might be asking, what's the difference between the THORNode as well as the Midgard? So THORNode takes, as we said, the raw data from the blockchain and is good for correct to the moment data. When you need to know a certain amount of information now, THORNode's what's good for that. And it's usually going to have more specific detail than what Midgard's going to have. Midgard takes the information and presents it more for interfaces. So there's a slight delay, no more than a minute or two, but it's designed to take the load off of THORNode specifically. Or at least that was the original design. Kind of like how within SQL, a reporting database is designed to take the load off a transactional database. Midgard also contains a timescale database, so you can look at historical information over a set period. So you want to know what's the transaction history over the last 90 days, 100 days, whatever. Midgard's going to be able to do that, but THORNode's not, as it's usually going to have specific correct at the moment data or block specific data. Anyway, let's have a look at Midgard and a couple of interesting points here. So we have like pool statistics, where you can get all the specific details of a pool if you were to add the asset. And if you go to put this in here, just say we go do this and go to bdc.bdc. So as you can see, this has all the specific information, APY, how much impermanent loss has been put out, as well as the depth, all this type of information that you might want that you're not really going to get from the THORNode API. Let's also, we've got a nice search function here. Let's also go have a look at details of the pool. This gives you the details of the pool, while the other one gave you the statistics. And you're going to get the Savers APR as well as the pool APR as well. So if you ever wonder what's the actual APR of the Bitcoin pool, then you can get it from this particular endpoint. There's also earnings history, so you can have a look at the earnings from a specific pool, as well as the global stats, which is also quite a good one as well. So what's the actual swap count over a certain time period, and so on and so forth. The last one actually I did want to show, because I'm going to show this one in a minute. This is a very powerful one. It's the action list, and this shows you all the actions, we could say kind of like history, that a user has had given a particular address as an example, or you can look at the actions within a transaction. It's quite a good endpoint for finding out historical information. So one last comparison is to have a look at the pools endpoint. The Midgard endpoint is going to give you a bit more information, like the APY, the Savers APR, as well as the 24-hour volume. So a bit more information you're going to get that's a bit more useful to interfaces, whereas this is a bit more raw information over here. So that's Midgard and THORNode. We're going to go delve into some THORNode endpoints, specifically the query endpoints, when we're going to have a look at how to construct a swap, and then we're going to look at savings. So for a swap, there's a nice guide here on the docs where you go ahead and you look for the specific asset you want. And you can see we've already looked at the pools endpoint here, and that's every asset we talk about or utilize within THORChain is going to be using a specific asset notation, which is fairly straightforward. So it's going to be generally chain.asset, or if you've got like ERC20, it's going to be chain.asset and then ERC20 contract. And then there are a couple of other ways to abbreviate this, but I just wanted to show that. When you have a dot, that's going to be a native. If you have a slash, that's going to be a synthetic. It's quite similar, but just wanted to point that one out. So you find the asset that you want, And then you can go ahead and swap, so from one asset to another. So as an example, we have this quote endpoint where we're going to be swapping 1 Bitcoin to an appropriate amount of Ethereum. And then when we hit that, we can see that the expected amount of Ethereum out is going to be here. And this is in 1E8 format, so you would need to format that accordingly. There's the outbound fee, which we got off the inbound addresses that we talked about before. This is going to be the inbound address you send your 1 BTC to. Now there are wait times. I'm going to go through this in a little bit more detail in a minute, but because we're sending in Bitcoin and Bitcoin's not an instant finality blockchain, THORChain needs to wait until that settles. And how long it waits is really dependent on the size of the transaction. So if it was kind of like an 8 or 9 Bitcoin transaction, you need to wait 2 blocks. And if it was like a huge amount, you need to make more BTC blocks. These are inbound transaction blocks. So one block confirmation is required, and then you would be waiting 10 minutes, obviously. Then the memo that you would need to send in order to perform your Bitcoin to Ethereum swap is this. And you're saying for the Bitcoin that's sent in, swap it to Ethereum and then send it to this specific address. Because this is a large swap, you need to actually wait. So THORChain has an outbound delay, and it's only going to process so much outbound liquidity every block, essentially. Now you need to wait approximately 118 blocks, and this quote endpoint is obviously working it all out for you. THORChain is 6.5 seconds per block, but it works out how many seconds you're going to be waiting. And the slippage basis points is going to be 30. So you just need to convert that into percentage there to work out the percentage and tell the user that. But these inbound confirmations is to understand specifically how long do we need to wait until THORChain receives it, and then there'll be a little bit of delay. I mean, it should be quite small for it to process it, and then how long before it's actually going to send the transaction out. So that's for swapping, and there's an example response here. Then there's also a replit. I'm just going to load this up and let it fire up whilst I'm talking. You can add additional parameters. So you can add price limits. So if you want to have a slippage tolerance, so most of it's like I want it under 1%, but if you want to protect yourself, you want to say no more than 2% or 5% slippage tolerance, you can actually put that in the tolerance basis points. And that's to ensure that no one's going to get wrecked by like a 50% slippage or stuff like that. And then you also have affiliate fees. And this is what we talked about before, where you can take a certain percentage of the inbound transaction for yourself. And that's always going to get sent to a THORChain address. So as an example, this would yield the same amount, but it would be talking about how much rune, how much affiliate fee that would actually generate here. And then that, because of the affiliate, it's going to change the expected output. The affiliate is taken out away from the liquidity before it's sent to the swap. Whilst I'm talking on fees, I might as well do it now. So we have a number of different fees here, and I want to go just to this specific ordering. So we have the inbound fee, and that's obviously going to be controlled by the wallet or whatever sends it in. Then you have the affiliate fee, and that's what we talked about before, up to 10%. And it's important to understand that it's taken out before the swap is processed. And that can be also done for savers. Then you have the swap fee, and the swap fee is essentially in other parts called the liquidity fee. And when we talked about our swapping here, that's the swap fee. And then there's the outbound fee, and that's what we talk about inside of the inbound addresses. That's this specific outbound fee, which also includes the network fee for the protocol. So the replit's loaded up, and we're just going to go run this. So I said we just ran this off here, and this has an example just hitting the endpoints, so you can have a look what it actually looks like. If I make this a bit bigger, it'll be nice. So these are the active pools that you can swap from or to, and you can see we run this particular endpoint, and to swap Bitcoin to Ethereum to this address with a 1% slippage tolerance. And then this is the expected output, so it constructs the memo. If we do it the other way around, we want to swap Ethereum, 15 ETH to Bitcoin, then we're going to get pretty much the same thing. We send the Ethereum in to this particular address, and that's the memo that we're going to need in order to produce that particular swap. If you're interested in this and you want to go have a look at the code, you just need to go show files, have a look here, and we can see we're sending 1 Bitcoin in 128 format, and then also we're doing the same thing for sending 15 ETH in with a certain amount of slippage tolerance. So we've covered swaps. Let's go have a look at savings. So with savings, there's also a quote endpoint, and you can just go hit it here. Let's go talk through it. So if we're going to send 1 Bitcoin in, then this is what we need to do. We send our 1 Bitcoin in, we're going to send it to the inbound address here, which is the same as from that inbound addresses endpoint over here. And this is going to be, the expected amount is going to be under 1 Bitcoin. It's going to be less than 1 Bitcoin. And that's because of what we talked about over here, how we enter savings. So there's going to be a double swap. So a little bit of liquidity is going to be lost as it goes through these 2 swaps before it gets to the savers vault. Now we haven't had an affiliate fee on this. There's no outbounds because we're sending liquidity in and it's staying there. And because it's Bitcoin on the way in, there's going to be 1 inbound confirmation, e.g. 10-minute wait time before it actually settles within THORChain. And this is the slippage basis points. This is the memo that is required. Then we have withdrawal. So we want to withdraw from our savers position, and that's similar to how we add, except we need to add how much we want to withdraw within basis points. So you can withdraw like 100%, 50%, 10%, a third, like whatever. You just need to specify that in the withdrawal basis points parameter. And we just have a look at this here. So here we're saying we want to withdraw 100% for this specific address. You may be asking, why does the dust threshold amount here say 20,000 sats to withdraw 100% here, when if I go to the inbound addresses endpoint, it clearly says 10,000 sats here? Well, within the withdrawal part, when you send the transaction in, you need to send in a certain amount of sats to kind of specify the withdrawal basis points, because you can have memoless transaction as well. If you have a look, it does do a bit more of a detailed example here, but just to show it, if I want to withdraw, as an example, 50% instead of 100% here, I would just go along and change my basis points to 50%, and then that would give a different dust amount. So this dust amount here is going to be this dust threshold amount within the inbound addresses endpoint, plus the withdrawal basis points that you want to remove. The expected output of this particular position is going to be approximately, this is how many sats you expect to get out. And then we've got affiliate here, and then this is going to be the outbound fee. This is where you send it to. This is going to be the memo. So the memo here is saying withdraw from the BTC vault, and we want to withdraw 100%. So obviously that you can change that to less than 100% if you wish. This is the outbound delay. So there is going to be an outbound delay of approximately this many blocks, and this is what it's going to be in seconds. So this is important to tell the user so they know how long they're going to be waiting before that BTC rocks up into their wallet, and this is going to be the slippage basis points. So just going back to the replit, put together some quotes for adding BTC to savers as well as adding Ethereum to savers. And then we've got the withdrawal. And when we look at the withdrawal, here it's got actually the percentage growth. So this is how much growth this particular position has grown since it's been entered. And then this is the quote for its actual output. So you would see like how much you're expected to get out based if you were to withdraw 100% now. And here we're looking at an Ethereum position and then the actual subsequent Ethereum withdrawal of 100%. One note, because of this entry and exit, if you were to put large amounts, just say you put 10 Bitcoin in, you're going to like lose a lot on slippage on the way in and on the way out. So it's best to break it up into smaller transactions so you incur less slip. I mean, dependent on the slip and the inbound and outbound fees, when you start adding them up, there's a certain amount of time or certain amount of yield that's going to be required for a saver to break even, because they're not going to be profitable straight up. They're going to need to gain back those fees that were incurred when they entered and then account for when they exit. So you kind of want to be in savings for a certain minimum time before you're actually going to get a yield because of the entry and exit fees. So we've talked a lot about how to get quotes for swapping and for savers and all the memos you need to put in. let's talk about how to actually construct and send these transactions. There's a page here that goes through the specific chains on what you need to do. So for UTXO, how you construct that, where you put the memo in. For EVM chains, where you put the memo in, and you can have a look at the router here, as well as BFT and THORChain specifically. So if you have questions on how do you construct and then send the memo, then this is the page you want to go consult. If you have any questions or this doesn't really do it for you, then do feel free to reach out in the dev Discord, as there's always lots of help available for anything that you might need. Before we leave the docs, I just want to show 2 more points here. So this is how you find the savers position, both within THORNode and Midgard, because they show different information. You just change this with the asset as well as the address, and it's going to give you back that information. And these endpoints are undergoing development, so they might change and improve over time. This is the action endpoint I talked about before. So you can put in any address here. It doesn't have to be a Thor address. So as an example, with this BNB address, we know that this user has had about 6 particular interactions or transactions, and it's going to detail it here. So if you were to, trying to build user transaction data, you can do that. This is an endpoint under development, but it's designed to track through the specific delays, you could say steps through which a transaction goes through. And it's going to be different for swaps as well as for savers. So swaps will go through the whole bit where an inbound transaction comes in. The nodes need to have a look at it. It undergoes conf counting if it's a non-instant finality blockchain, so like UTXOs, or if it's going to be instant like BNB or THORChain, then this is not going to apply. Then it's obviously going to be processed, and there's an outbound delay because THORChain will only process a certain amount of outbound liquidity every block. And then there's obviously the layer 1, the actual blockchain time from when it's sent out to when it's actually mined in a block and spendable within the end user's wallet. You can read more information about this and every step within this page here. Last, I wanted to show an example implementation for THORChain. And xchain is a library written in TypeScript or JavaScript that you can utilize, get ideas from. It has a number of different packages from the client package that enables you to go ahead and get as much querying information, kind of like read-only information. And then there's the AMM package, and they actually do the actions, like the actual swaps, the adding and the removing from savers. And then there's chain clients. We'll just have a look at each one individually. So the query package, you can query and estimate swap with examples using replets, savers, check balance, check transactions, add liquidity, a bunch of information here. Then there's going to be the AMM package for actual swapping and actually doing savers. And again, at any time, you can just do show files, have a look at the code, see if that works for you. You can actually just copy that. That's for anyone to use. You probably have to put your own seed in there. And then you can have a look at the package JSON for all the dependencies and what you need to install to get yourself up and running fairly quickly. Then there's client packages, and this is like really good because all that client specific stuff is taking care of it for you, so you don't have to worry about all the chain specific nuances. It's all there for you, and this particular example wraps everything up into a single wallet class that works with the AMM and query package. So it's kind of like it's all done for you on a silver platter if you use TypeScript, and if you don't, you've still got the quote endpoints that you can utilize and the Open API endpoints that you can use to build that into whatever language that you want. Before we wrap up, just wanted to go through 2 more sites. So we've got ViewBlock. This is a block explorer, and it shows you lots of really good information like the addresses to find transactions. You put your transaction hash or address or whatever you want in here. You can find the pools, you can find the nodes, you can find lots of information here, as well as a nice little fancy dashboard. There's also, whilst that's loading, THORChain.net, which we covered before, and that has lots of helpful information if you're trying to get to network settings, if you're trying to get to the pool status, like lots of information. Spend some time exploring so you can actually have a good look at it there. And then there's this particular website here. You can get charts and whatnot from as well. Actually, Insights has good chance, but then again, I showed you the stats endpoint from Midgard. That's going to have all this type of information as well. So that's the video. I've covered a lot of information here regarding THORChain, how it works, a bit of an overview, sending information to THORChain. If you need more information, we've got the docs here, we've got the dev docs here, going through all the information that I've gone through. If you have any questions or you want help and stuff like that, there's the dev Discord. You can get a link here. I have many videos on THORChain and how all that works as well. So you can ask me or put some comments in the comment section below. If you like this video, hit the thumbs up and subscribe to see more content like this. Thanks for watching. Until next time.